With 128 gigabytes of super fast LPDDR5X memory, 16 cores, 32 threads, and a giant integrated GPU, this thing is awesome for both gaming and for AI. This is a completely new era of mini PCs, so let's get to it. Hey guys, this is Patrick from STH, and this is a GMKtec EVO-X2. This is a new generation of platforms where the integrated GPU is not an afterthought or like, hey, maybe you can have okay graphics. Instead, this is a platform where not only you have that fast CPU, but you also have a GPU that is integrated, yet it's equivalent to a lot of the discrete GPUs that we've seen previously. Now, normally when we talk about GPUs, we talk about gaming, but one of the coolest features on this system is being able to partition the CPU versus GPU memory in ways that make this an awesome little AI box. And because of that, we really have two things to cover today. One, we have this GMKtec EVO-X2, which is the system that it comes in, but then we also have to talk about the processor. The AMD Ryzen AI MAX Plus 395 is absolutely awesome, so I guess the second question is, can this system take advantage of how awesome the processor is? With that, let's get to the hardware. Okay, the first thing I want to talk about is just the size of this GMKtec and how I think it's supposed to be oriented. So here's the overall unit, just kind of taking a look at it real quick. And I figured let's go take an HP. Now this is an EliteDesk 805. So this is somewhat equivalent with an AMD Ryzen processor plus a discrete GPU, and it would be kind of in the same class as the system. So I'm just gonna put this right here, and something you'll see is that this GMKtec box is absolutely much larger. But the other thing is just the orientation of it. For the longest time, I thought you were supposed to put the system like this, but that's not the case. Instead, you'll notice there are no rubber feet on this side, only rubber feet over here. And so you're actually supposed to put the little system like this, which is kind of different. I was not really expecting it to be a little mini tower, but I guess that's what it is. Now turning to the front I/O, we have a power button, which is nice and clicky. Also lights up to show you that it's actually on, which is always nice. There's a little performance mode switch, which I guess is okay. There's also a full-size SD card reader. And then you get a USB 4 port. This is a Type-C port, always useful for doing all kinds of expansion. Next, we get two USB 3.2 Gen 2, and these are Type-A ports. Then you get a audio jack, which is always just kind of useful. Now turn to the rear of the system, we have our DC power input. Then we have another headset jack. So if you really are an audio enthusiast, I guess there are different options here. We then get a network port, which is a 2.5 gig Realtek 8125BG, I think. I kind of wish that in a platform that's cost around $2,000, I just feel like you should get 5 gig or 10 gig. Next to that, we get another USB 3.2 Gen 2 Type-A port, and then we get a Type-C USB 4 port. There's also a display port and an HDMI port, followed by two USB 2 ports. Something else that you're gonna notice is that we have a ton of cooling in here. You can see that there's this giant cooling thing here. There's more cooling vents on top. I mean, this whole thing is designed to dissipate quite a bit of heat actually, and we're gonna get to that in our power consumption section just in a little bit. But instead, I wanted to talk a little bit about how you get inside the system and what you can actually upgrade. To get inside the system, it's a little different than a lot of mini PCs. So you see this like kind of clamshell design, and you can actually lift up, and it feels like this thing should just like lift away or break away or something like that, and that's not really the case. Instead, you have rubber feet over here, and you actually have to pull these rubber feet off to be able to get inside. Now, once you're inside the system, you'll notice that we have a giant fan, and this fan is actually an RGB fan that, I don't know how useful having an RGB fan in here is. It's just kind of the fan inside the chassis doesn't make it light up in any kind of spectacular way. The other thing though is really the service. So to get to the M.2 slots, it's not a super easy way to get in through this chassis, which is kind of a bummer. I wish that it was a little bit easier to go and service the M.2 drives. You'll also see that we have our Wi-Fi here. Now the cool thing is that this actually has Wi-Fi 7, which is an RZ717. And so you actually do get decent network performance. Now I don't think that in a system like this, you're going to upgrade the Wi-Fi 7 to something else just because that kind of is a pretty good solution. But on the other hand, getting to that Wi-Fi slot would be just a total pain in the butt if you ever wanted to change it out. So I think between the two M.2 drives, as well as, frankly, just how hard it is to get into all this stuff, I just kind of feel like I've seen much more serviceable designs in so many of the mini PCs that this feels like a step backwards. Now, both of the M.2 slots are PCIe Gen 4 slots, And in this system, we get a 2 terabyte SSD. Now, frankly, I really like the idea of these mini PCs starting to use 2 terabyte SSDs solely because the difference in price a lot of times between the 1 terabyte and 2 terabyte models is not huge. And especially in premium models, I'm starting to just not like as much when you start getting 1 terabyte drives instead of 2 terabyte drives. Now, of course, you could go add another 2 terabyte drive. You could add like a 4 terabyte drive or something like that and get more storage, which I think is useful. But again, to do that, now you're gonna go and have to peel off these rubber feet, take screws off, get inside, and it's a pain in the butt to go do it. So I wish that this was a little bit more serviceable, especially when you start talking about like a $2,000 PC. I will note that there's a 64 gig and 1 terabyte version that is $500 less, but the important thing here is that you cannot upgrade. This is LPDDR5 memory, so you cannot upgrade the memory like just by throwing SODIMMs in. So on one hand, you get faster memory, but on the other hand, you lose that upgradability. And what that practically means is that you have to pick, do you want 64 gigabytes or 128 gigabytes? And you also can't just go and buy like a bare bones and hope to add 128 gigabytes for the vast majority of people. That's just not something that you're gonna go do. And despite the fact that it is $500 more, and a lot of you are gonna watch this and say, hey Patrick, you've done reviews of mini PCs. There are other options out there that you can buy an entire mini PC for under $500. That's a lot for, essentially 64 gigabytes of memory and 1 terabyte and all that kind of stuff. It is, but on the other hand, I think folks, especially when you get to the AI side, are going to be more than happy to go spend that $500 because it just is a different class of device with that 128 gigabytes. And the reason for that is that this uses the AMD Ryzen AI MAX Plus 395, which is a complete mouthful, and I wish there were just a few things to describe this chip, right? But what it is a 16-core Zen 5 based processor, but instead of having a weak integrated GPU or a mediocre integrated GPU, this thing is absolutely great. It has 40 RDNA 3.5 cores, making it a significant step up from something like the Ryzen AI 370 that we've looked at previously. With that, I think it's time to get to the second set. Okay, so let's talk a little bit about the power consumption and the noise on this system. So the first thing that you'll notice is that this system at idle is actually kind of quiet. In our 34 dBA noise floor studio, we're getting maybe 37.5 to a little over 38 dBA with this at completely idle, and that's pretty darn good. Now, sometimes what happens is that, even just opening something like Edge or what have you, you'll see that the power consumption goes from maybe the 6 to 8 watts at the low end to maybe like 12 watts at idle, all the way up to maybe 12 to 20 watts with just a web browser open. So you do see a little ramp there. When that ramp happens, you'll also see the noise ramp up to like 39, 40 dBA, somewhere in there. So the weird thing about this is that at completely idle, this system is extremely quiet. On the other hand, once you start opening things, you definitely start to hear the fan. And that of course applies not just to when the CPU is loaded, but also because this has such a big GPU. When we start, really loading the system, even doing things like running an LLM or doing things like playing a video game, you are gonna see that completely the noise on the system increases significantly. Let's just go and show you what that looks like. So we're gonna run this Llama 3.370B Instruct model right here, which is about a 53.91 gigabyte model. Okay, and just real quick what's happening here, you can see that we're loading it into the GPU memory, we're loading the model also into the CPU memory, and when you look over here, we're already at about 60 watts or so. But the noise at about 1 meter is now hitting 41 to 43 dBA, and we're not even doing AI inference yet. Okay, and now let's do something fun. Let's just do a what is ServeTheHome and see what this does and how fast it goes. So you can see this model is so big that it's actually too big to fit even in like, a NVIDIA L40S GPU memory by itself, yet we're still running it no problem on this kind of system. Now, when we click over and just kind of look at what the GPU is doing, you can see that we do have only 38% GPU compute. We're using a decent amount of memory here, but we're also now offloading things to the CPU. So this is a mix between the CPU as well as the GPU. On the other hand, doing that mix, we're at about 44 dBA, and we're going between about 100 and 175 watts. Okay, now nobody wants to watch the system go slowly doing this, but on the other hand, we've got 2 tokens per second, not too great, but we also got a pretty good answer, right? With my name, we also got the 2009, which is actually the date that we founded the website. I have to say I'm pretty impressed by what we got. Okay, but now let's switch and let's do all GPU offload. So you're gonna see here that we're using a lot more GPU memory, but on the CPU side, we're also using a little bit less memory. And we're gonna show you what this looks like running all off the giant GPU that's in here. Okay, so that definitely took a couple seconds, but just showing you what happens now that we've loaded a bigger model. We have a pretty giant model loaded all in the GPU memory. We've also now unloaded a lot of the CPU memory, and now let's go look at what happens when we go directly onto the CPU. So now we are doing our what is ServeTheHome again. Let's see if we get another good answer. And we'll let this thing just kind of rock and roll for a sec. You can see though that this is much faster than when we had it split on the CPU and the GPU. We're just using this 64 gigabyte, or at least a model that fits into that 64 gigabytes of GPU memory because, well, we want to talk about other systems as well. Now, one of the cool things is that when we do this, we're now topping out at only about 147, 150 watts or so, but it's a lot more consistent than we had both the CPU and GPU running. Our noise is also in the 41, 42 dBA range, which is much better. Just bringing up Task Manager again, you can see that we're only using 3%, so our CPU is basically idle. We're using a little bit of memory, but we're not using the onboard NPU. We're using all GPU for this, right? So that's just something to keep in mind when we talk about what kind of performance we're getting here. And so just switching from CPU and GPU to GPU only, we are now running a giant model at about 3.7, 3.8 tokens per second. And that's without, by the way, any tuning. So usually when we start doing tuning on some of the values and stuff, larger batch sizes, what have you, we can oftentimes get, twice the performance. And so I just want to point out that that's like just literally you open LM Studio and that's the performance you get. Also, AMD has said that they're going to focus some of their ROCm GPU compute improvements on this Max Plus 395 platform. And so what that should mean is that we get better performance over time. We're actually doing this before the system is even released. So I would say that this is definitely not the most tuned that you're going to see this. And I thought it's worth just kind of showing you what a smaller model is. So we're using the Qwen 3 32 billion parameter model. And what you'll see here is that our memory has gone down significantly using a much smaller model. We're now only at 21.7 gigabytes used, which you can see here. And let me just kind of show you how fast a smaller model goes. So we're gonna do what is ServeTheHome again. Okay, so this one just finished, and you're gonna see that it is much faster at 10.42 tokens per second. So much faster than that Llama model that we just ran. But the flip side to this is that Llama model had a great answer, whereas this just is completely useless as an answer. So I think that's an important thing, right? Is as you're able to run those larger models on a platform like this, you're also able to get much higher quality results. So there are a lot of folks that are just looking for straight speed, and there are of course options for that. But on the other hand, I really think that the ability to go and get higher quality models and get something that is going to be useful, even though it may be a little bit slower, I think is really awesome, right? Okay, so let's talk really quickly about gaming here for a sec. This is Counter-Strike 2, and a lot of the mini PCs, I think you can play Counter-Strike 2 and it's pretty decent, but I just want to show you this real quick. We're actually running at 120, 130 FPS on Dust 2. So first off, getting 110, 120 FPS is pretty darn good, and it's definitely playable, especially on most models. This also has all the variable refresh rate and all that kind of stuff, like FreeSync that you would expect from an AMD GPU. In terms of power consumption, when we're playing, we're getting here at 4K. We're running somewhere in that 170 to 180 watt range pretty consistently. And so that's, we definitely use a lot more power than we're even seeing when we're doing our AI, right? But the other thing is that I can hear the system. We're currently at something like 43 or so dBA on here. So it's definitely, I can hear this while it's going right next to me. Now, just as a quick thing, we also tried this at 1440, and you are certainly getting, into that 180 plus FPS range, right? So something that is, I think, completely playable. Now, Counter-Strike 2, I think, is a super interesting one because, frankly, this is not the hardest game by any means. But on the other hand, when you are on a lot of the lower-end iGPUs, you're not going to be able to maintain a high FPS. And so I think that that's interesting because a couple things. Like one, if you're just starting out, like Sam, who's actually behind the camera here, he would tell you he tried gaming on this and he was like, this thing is absolutely fine. The system is not holding me back. It's just, I've really never played this. So at Sam's end of the spectrum, I think that this is completely playable and, he's not really having any issues with latency or something like that. Now, on the other hand, if I were to go play this and do it in competitive, like if we're playing Premiere or Faceit or something like that, just giving you an idea, I'm probably about 26,000 and change ELO on a Premiere or something like that. I'm definitely a lot slower than I used to be, but at the same time, I would definitely notice playing on a platform like this versus one with a dedicated GPU. We don't really cover games on STH that much, but this is the first system that has an APU that I'd say, if you're especially playing esports titles, not only can you play it, but I think for the vast majority of players, this is going to be absolutely all they need.
Okay guys, so the other thing I think though in terms of performance, let's talk a little bit about the CPU and GPU performance just kind of at a higher level. You know, when we look at something like our Ryzen AI, like the 370 or something like that, you'll see that the 395 is certainly similar actually in terms of the performance to compare to a lot of other systems that we've seen with a 16-core AMD Ryzen Zen 5 CPU. We just looked at something like the Minis Forum MSA2, and that was maybe a little bit faster even. But overall, I think, you know, that 16-core Ryzen range, I think folks know what that is these days. And this is a good example. It's not just a big GPU, it's also a big CPU. But when we go look at something like the Ryzen AI, that 370 compared to 395 on the GPU side, even using something as simple as Geekbench, we're talking about maybe 2.5 times as fast on OpenCL compute performance. And you definitely notice that AI, gaming, pretty much anything that you use a GPU, you definitely notice that. Now, on the other hand, I will note that this thing certainly uses more power. We're often seeing somewhere in the 150 to 200 watt range when we're really using those compute resources. And the other thing is that this thing is not silent. Despite the fact that it has these RGB fans and all that kind of stuff, it is far from a silent system. As I'm recording this, I can even hear the thing next to me, and that's just becoming very apparent. And I think why that matters is really just this form factor, right? This is a pretty cool little mini PC, but on the other hand, if you told me that you could get me a little bit bigger of a mini PC and you could get a quieter mini PC, I think I would take that any day. To me, the space savings between this and something that's maybe a little bit bigger, so you could put like 120 millimeter fans, is just not great enough that I feel like I really want that smaller PC with this much power.
Okay, now with all of these videos, I love to have key lessons learned. I mean, what do we learn about this platform? So I think I learned a couple of things that are really important. Now, first off, let's put this into context, right? This is a $2,000 mini PC. If you're not going to use like the high-end AI features, if you don't want a discrete GPU level of performance, then I don't really think that this makes a lot of sense, because you just can get something that costs half as much and still does a lot. It's really if you just need that little bit extra. And in terms of what do you need that little bit extra for, I think on the gaming side, it's a little confusing, right? Because we're talking about this being as fast as a desktop RTX 4060, for example, on the NVIDIA side, or a RTX 4070 mobile chip. But on the other hand, you can find systems with those two discrete GPUs that cost less than $2,000. So I don't necessarily think that just from the standpoint of like, is this the only option that you have in this price range, and does having an integrated GPU, does that really benefit you a ton when it comes to just playing games? I don't really think that's the answer, although I think it is a very capable gaming machine. Instead, I think the real reason you do it is to run those AI models locally. Being able to run large LLMs, or even things like Stable Diffusion 3.5, and like run big models and stuff to go and create images. I think just from a generative AI standpoint, having something that you can have either 64 gigabytes or 96 gigabytes of memory puts the GPU memory of the system in the class of something like a Mac Studio. And on the NVIDIA GPU side, to get 96 gigabytes of memory, you pretty much need the NVIDIA RTX Pro 6000 Blackwell edition, which is of course faster than this. But on the other hand, that's also like a, I don't know, $8,000, $9,000, $10,000 GPU. On the flip side, if you just want that 64 gigabytes memory, you're even out of the L40S class, which would be a 48 gigabyte class GPU, which is a little over $6,000 these days. So to me, the big benefit of this is really getting that LPDDR5X memory, having a decent sized GPU, and being able to have a lot of video memory that's dedicated to the GPU, that if you got a discrete GPU with GDDR, say 6 or GDDR7 memory, it would cost a ton more. So compared to a lot of mini PCs, this is actually quite costly, but compared to getting 96 gigabytes of GPU memory on a system, this is actually pretty inexpensive. Now, something else I want to point out that happened somewhere between like when we recorded some of this video and like right now, is that AMD actually released a new ROCm version, ROCm 7. And as part of their whole release and their Advancing AI 2025 event, one of the big messages was that this AMD Ryzen AI MAX plus 395, just giant gobbledygook of a name, is going to be a platform that AMD expects to really focus on in terms of supporting on its AI efforts from a software side. And that's important, because if you do want to go develop, and you want to go develop for the big memory GPUs that AMD has, like the AMD Instinct MI355X, and you want to learn ROCm and all that kind of stuff, then really AMD needs a platform that can go all the way from notebook up to those high-end GPUs this. And so what they're saying is, hey, we understand we're gonna do our thing in the data center side, but on the, on the desktop and mobile side, this $395, this is gonna be our answer. And so I think from that standpoint, it actually makes a lot of sense. And for me, this is a super exciting platform. It's not necessarily the fastest AI platform you can get. There's plenty of those, but on the other hand, for the price, it's actually pretty darn capable. I think from a system perspective, there are a couple things. Like one, even though it seems like we have really good cooling on this, we keep getting temperatures that are in those well into the 90 degrees Celsius range. So even though this is a larger system, I just kind of feel like, hey, if it was even a little bit larger and they got better thermals, that would be a big benefit. The Wi-Fi 7 I think is great, but on the other hand, if I want to go do my storage, well, now I have to go and open this whole thing up and it's kind of a pain to get in there. So I would say that, from a serviceability standpoint, that would be the one thing, because those are really like the two SSDs are the things that like you could go service easily, and I feel like they should just be easier to get to. The other one I just keep coming back to is like this 2.5 gig port. If this was a 5 gig port or a 10 gig port, that would be super exciting. Like a $400, $500, $600 mini PC, I get why you don't do the upgrade to like 5 gigabit or something like that. But on a device that's like $2,000, like I want faster networking. Now guys, we covered a lot today. If you did like this video, well, why don't you share it with your friends and colleagues? And also if you did like it, well, hey, why don't you give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.